So from time to time, I actually really like my TI-83 or 84 or whatever version you have, because in this lesson, we get to graph exponential graphs. And we get to talk about exponential growth and exponential decay. I always like to keep in mind the things I want to see grow and the things I want to see decay. Um, but we'll have fun talking about radiation, bacteria, occasionally money, and other things that go bump in the night. Not quite. New term. We want to look out for this in this lesson. It's not formally defined in our lesson notes, so I'll start with that. It's the term asymptotes, a line which can be really in any direction. In this class, it's primarily going to be a horizontal line or a vertical line. In calculus, it will be a line that is at a diagonal, and they're fun to find. A line in any direction whose distance from a curve approaches zero, or a line that the graph does not touch or cross. As we explore graphing today, please look out for those limits. They're like boundaries on a graph, and those boundaries provide interesting restrictions for domain and range, and possibly non-permissible values. In the last lesson, I talked about exponential growth, bacteria question. Here, a bacteria question is presented, as well as a story on Chernobyl. We're actually going to get right into graphing on our own. Feel free to check out the example, but we want to go into the graphing of the pages to come. I'm actually going to ask you to do some graphing. Turn the page over. So the nice thing about you and your calculator is that you can create a graph. You can create a graph of y equals 2x and y equals 1/2 x. And I'd like you to plot those. We are going to start talking about connections to the past chapter. So we're going to get like the letters A, B, H, and K back, which is kind of frightening. So just because that unit is done doesn't mean you can't forget them. So in this example, what is the value of A and what is the value of B? Pretty clear what A and B are. A in both cases is 1. That's the coefficient of our power. In the first statement, the B value is 2. In the second statement, the B value is 1/2. If you scale your graph from -10 to 10 and 10 to -10 in the horizontal and vertical respectively, you can get a nice sketch of that. Here I find the word asymptote hiding, so that's good. Build those graphs. Y equals 2x, y equals 1/2 x. Get used to finding a table of values. So you can set your table of values to start at -3 and write them down and plot, and repeat that for the second graph. And now when we look at the graphs that you've created, you should be able to give me statements of domain, range, x-intercept, and y-intercept. And actually the asymptotes came up here. I didn't look quite far enough down this page. The asymptote in both cases, what line does the graph not cross? So as we take a look at some graphing terms, x can be anything. That's fantastic for both of them. The range, y is restricted. Y has to be greater than 0, which is why there are no x-intercepts, which is why there's an asymptote at y equals 0, which is technically the x-axis, and the y-intercept of the graph is 1. If I have an example graph like y equals 2x, that shows growth. That's an example of a growth function. And the other one, when it's a fraction raised to an exponent, that is a decay function. Growth and decay. Let's turn the page over. Again, you've got some room to sketch a graph. You'll notice that the graph has been sorely defined by very little in the y-axis. Please draw a sketch and label them y equals 3x, y equals 10x, y equals 1/3 x, and y equals a 10th x. Again, using different colors. Consider using colored pens or pencils to note the difference between these graphs. How do they change? So I hope you had some fun graphing while I was trying to record. Mr. Epp was trying to get in on my recording, but I found him. Some conclusions about our b values. When b was greater than 1, like the first two graphs, the curve rises more sharply as b increases. And for the second two graphs, when b is between 0 and 1, the curve falls more sharply as b increases. So you can envision that if I choose a b value that's in between 3 and 10, the graph of y equals 5x will fall in between the graph of y equals 3x and y equals 10x. The graph of y equals 0.2x. Where is that? Well, just a quick thought, 1/10 is 0.10, so where would 0.20 be? So 0.20 actually falls between the previous two graphs as well. Remember, these words are increases and decreases. I think I said one of those incorrectly. You can throw those on your graphing calculator. X-intercepts. What have we learned about x-intercepts? Correct, there are none. The y-intercepts for each of these graphs, what were they? Try to get that on the graph specifically. 1, state the domain of the graphs. The domain x is an element of the reals. There are no restrictions. State the range. Y is always greater than 0, and y is also an element of the reals. And in this case, we get to look at the equation for the asymptote again. Remember, we cannot cross the x-axis, which is a definition of y equals 0. All right, I've turned over the page. We have another opportunity for you to demonstrate with colored pens of some sort the 4 differences in the graphs illustrated. I'll get those graphs up there in a moment. So as I'm getting these graphs on my calculator, I'm trying to focus in on the y-intercepts. And the y-intercepts are something I want to catch when I graph. The y-intercept of the first graph is 1, the second graph is 2, the third graph is 5, and the last graph is 0.5. What's happening to these graphs? We've got stretches that are happening. Stretches are happening in our graph, language from before, SRT, stretch. Let's get those graphs done. So my graphs are up there. The value of A, the value of B, and then the y-intercepts. Remember, your A values are the values that are in front of the function. So my A value is 1, 2, 5, 0.5, which corresponds to my y-intercepts. And my B value is the base. My B value is the base. In each case, 3, 3, 3, 3. So we've got the language of stretch. Stretch vertically when we're working with A about the y-axis. Stretch vertically, pardon me, about the x-axis. You're stretching vertically. So using function notation. Remember, we were struggling with this earlier. Let's try it out. So we've said the word stretch often enough. Transformations, you're getting vertical stretches. Vertical stretch, VS of 1, 2, 5, and 0.5 on the function. So the parameter A is doing vertical stretches for us. So I like what the policeman has to say here. All the things we've concluded in this exercise. The y-intercept is A. There are no x-intercepts. The x-axis is a horizontal asymptote, which is defined by y equals 0. The domain is x can be anything. X is an element of the reals. The range y is greater than 0, and y is an element of the reals. If b is greater than 0, we have a growth function. If b is between 0 and 1, we have a decay function. When b is greater than 1, and the curve rises as b goes up. When b is between 0 and 1, the curve falls sharply as b decreases. And then we've got the effect of a. When a is greater than 0, we actually have expansion, and then we've got the notion of compression, which is still talking about a stretch, but it's actually a reduction in size when a is between 0 and 1. And when a is less than 0, there is also a reflection in what axis? So that's the reflection in the x-axis where y becomes negative y. So a little bit of graphing discussion and then one example, and we're done this lesson as well. I see my a value at 2. That's a vertical stretch of 2 about the x-axis. I see my h value at 2. Not sure how you like reading h, but I have a horizontal translation, 2 units to which direction? Trying to stay within my time limit without using a graphing calculator. Remember, you always have one, so that's nice to deal with. The domain and range of the function. When you look at that, what do you see? I want to start envisioning what my graph is doing. I see an h value and a k value. My h value is focusing on the 2, and my k value is focusing in on the -6. X is still not going to give me any troubles, although I do see a shift of 2 units horizontally to the left. The 6 is 6 units down, which is going to have an impact on my y. My y will actually be greater than -6, and y will still be an element of the reals. My x is an element of the reals. The y-intercept of the function, where do you get y-intercept from? You have to figure it out. Y-intercept occurs when x equals 0. Well, let's figure that out. 4 times 0 plus 2 minus 6. That's 16 minus 6, which is 10. I couldn't read that off very easily. We'll practice that. And the equations of the asymptotes. What line does the graph not cross? Well, I managed to stay in my 15-minute limit. The asymptotes are down at y equals -6. That's because I've taken my x-axis and shifted it. Check out the assignment on your pink paper, and thank you very much.